All right, so today what we're going to be doing is we're going to be doing a bubble experiment. So as you can see right here, we've got 3 different types of homemade bubble wands. So our first shape that we have is a triangular pyramid. It looks like a triangle on 4 different sides of the wand. For our second bubble wand, we have a cube or a rectangular prism. As you can see, it's got all the sides are squares. And then for our third wand, we have a polyhedron, which is a shape that has many different sides to it, or in our case, a shape that has 8 different sides. For our experiment, we want to see if our 3 bubble wands will create different bubbles or if they'll all be the same shape. Bubbles are made of 3 different layers. So they're created of a soap layer, and then a water layer, and then the final layer is soap again. Here we have our 3 wands. The first one is a pyramid, our second one is a cube or a rectangular prism, and our third wand is a polyhedron. Alright, so we're going to take our pyramid wand and we're going to dip it into the bubble solution. So, as you can see, all 4 sides of the wand are covered in bubble solution. Okay, so you might notice if you look really closely that in the middle of our bubble wand, you can see that there are almost distinct triangles formed from the bubble solution. So this is because the water in the middle of that soap layer is attracted to the water in the other soap layers on the opposite side, and they want to come as close as they possibly can to each other and are separated by the edges of our triangle. Our second bubble wand, our rectangular prism or our cube, we're going to do the same thing where we dip it into the bubble solution. We want to make sure all of the sides are covered, so we're going to kind of squish it in there. So when we take it out, you can see again that all of the sides are covered in bubble solution. Once again, you can see that the bubble solution likes to come in as close as it possibly can. And here it's really clear that when you look at it, that you can see that the edges are separating and holding the water molecules inside the bubble solution apart from each other. Next, we're going to be using our polyhedron bubble wand. We're going to dip it in the solution, and then for this one, you kind of really got to squish it in there. We pull it out, once again, all of the sides are covered in the bubble solution. So this is probably our best example of how, despite the water inside the bubble solution wanting to stick in as close as it can, the edges of our bubble wand really hold the solution apart from itself. Alright, so for our experiment, we're going to start with our pyramid-shaped wand. Next, we're going to try our cube-shaped wand. What kind of bubbles do you think this one will make? Last but not least, let's try our polyhedron-shaped bubble wand. Alright, well my assistant, Lehigh, demonstrates more bubble blowing with our wand. Let's talk about our experiment. Despite having 3 different shaped wands, all of them blew spherical shaped bubbles. But why did this happen? Remember how we talked about bubbles being made of 3 layers? And how the edges of the bubble wands were keeping the water molecules in that middle layer apart from each other, despite how much they wanted to stick together. So, when you release the bubble from the edges of the wand, the bubble solution tries to go to the smallest shape it possibly can, which is a sphere. So, did you know that bubbles evaporate because the water between the soap layers evaporates? Which means that on a cold day, when the water is super cold, it'll take longer to evaporate, which means that the bubble will stay in the air longer than it would on a summer day. Also, did you know that bubbles get their rainbow color? Because as light shines through the soap layers, it distorts it and causes the rainbow to occur. Thanks so much for watching my video, you guys. I hope you learned some new interesting things about bubbles.